Hello everyone and welcome to the latest episode of the Modern Brewer Podcast with me, your host, Chris Lewington. Firstly, an apology for the regular listeners who have had to wait the extra week for this episode to be released. I did have some pretty big technical issues with this recording, and I had to postpone past the last due date that I could get this episode out. So that's totally my bad on that one. I was trying to balance too many things, and I was trying to do a recording remotely from a different country, and it just quite frankly didn't work. Surprise, surprise. So a big thank you to Alix for taking the delay in a stride and getting the rescheduled recording sorted. This episode is actually kind of a special one. The Modern Brewer Podcast is officially 1 year old. Woo! It's one of those years that when I look back, I actually can't work out if it's been the quickest year of my life or the longest. Either way, it's definitely been a journey. I started the Modern Brewer Podcast with one microphone and, absolutely zero knowledge of audio quality, editing, platforming, marketing, or actually, to be honest, any idea of even how to host a podcast. So for all those people who've stuck with me through all of those issues, I appreciate you so much. But all of those skills are actually easy to learn, especially when you learn by doing like I do. So it's amazing that I have also started to get industry members to sponsor the podcast, which has just helped me balance the books of all the various subscriptions it takes to run a podcast these days. But to be honest, the thing that really motivates me is hearing from people, the listeners, about how a specific topic or guest or even just one specific comment has really resonated with them and helped them become better brewers. So just a huge, huge thank you to everyone who has listened from the start, and for all those who've joined at any point along the way. Even if this is your first episode, I really do appreciate it. And an extra special shout out to my dad, who has never brewed a beer in his life but still listens to every episode. Probably the hardcore fan. Absolutely really love that. Here's to another year of great guests, of course. Niche subject matter. Yeah, so here's to another year of great guests, niche subject matter, and endless technical issues. Talking of great guests, today I have Alix Blease from Lallemand. This episode is targeted at brewers looking to repitch their yeast for the first time. So we're going to cover everything from start to finish. And by the end, you should have the confidence and understanding and the know-how to stop the dreaded pitch and ditch. And you need to start maximizing the yeast that you purchase. So if you are already repitching your yeast, don't drop out just yet. I am sure you will find useful information, tips and tricks, and I guarantee you'll want to confirm that you are repitching your yeast in the most that you are repitching your yeast correctly, and that there might be a more efficient way to do it. So just before we get started, just another request from me. If you do enjoy this pod, please ensure you tell your friends and work colleagues, or share the podcast on social media. I am desperate to expand the reach of the show, and your support in doing so would be unbeatable. For the many who already have and continue to do so and recommend the podcast, thank you so much. It honestly does mean the world to me. Okay, so let's kick on with this episode. Welcome to the show, Alix Blease.
Hello.
Wow, brilliant. Hey, thanks for coming on. I appreciate you're always busy, so it's nice to find the time. And I'm also apologize to the listeners who are listening to this a few days late. This was because I had a massive audio problem trying to record last time. So put my hand up and apologize to you publicly as well, Alix.
Well, that's very kind of you, but these things happen. So quite all right.
Yeah, one of those things that as I started recording, I was like, this isn't working. So yeah, look, Alix, not everyone will know who you are, although they should. If you could introduce yourself to the listeners, that would be wonderful.
Yeah, no worries. So my name's Alix. I have been in the brewing industry for 8 years now. I have been a technical sales manager for the UK with Lallemand for basically dead on a year now. I made the move from commercial brewing into technical sales, as I said, a year ago, and thoroughly enjoying it. It very much plays into my science background. Before I was a brewer, my master's was in chemistry, so I really enjoy the technical side and the communicating science and trying to make difficult concepts a bit more approachable and scientific concepts more acceptable and more understandable by the public. And I feel like everyone benefits in that scenario.
Yeah, I love that. And I've spent a lot of time reading very technical papers before and gone, I have no idea how this translates into what I actually need to do.
Yeah, I think it's almost like you need a filter between that kind of like, I definitely found that when I did my chemistry degree was you kind of learn how to read scientific papers. A lot of published scientific work, there's big sections in the middle that actually you don't even need to read or sift through because it will just be the process by which they gathered their data. So I always go with read the abstract, read the intro, read the conclusion, and then if there's any little bit you can't or you want to dig a bit deeper into, then normally that's within the body of the text. But it can be quite daunting if you haven't come from that kind of world or that kind of academic experience where it kind of is incredibly unapproachable. And also science isn't freely accessible to everyone because a lot of these papers are behind paywalls.
Yes, they are. Yeah, it's quite annoying that actually sometimes. Yeah, that's really interesting actually. I really like that approach, just reading those 3 parts. You could probably do quite well by just reading those 3. I'd never really done that. I always get bogged down with the details and I'm like, oh my God, I'm learning
To be
so
honest,
little.
you don't even need to read anything. And a lot of the time, sometimes the graphs, which are actually normally not behind the paywall, the descriptions, the figure descriptions tend to be pretty good at describing quite a lot of the concept within a paper. It just depends on, honestly depends on the author.
Yeah, absolutely. This is just a rogue question I'm going to ask you right now, but is there any sort of books or papers on yeast that you strongly recommend people read? Is there something you're like, that was outstanding for me and I really learned a lot?
I've been reading lots of papers recently on biotransformation, which I'm really enjoying. They can get kind of in-depth and nerdy, and sensory science as a whole is like quite, well, as a chemist, it's not a quantifiable science particularly. There's a lot of personal preference that plays into it, which for someone who likes knowing the right and wrong answer to things is quite annoying. But yeah, there's quite a lot of papers. I think the best place to go if you're looking for like brewing science papers is to look up concepts that you are interested in and then finding articles online that have references at the bottom and kind of starting there. And then when you look at those papers, if you see an idea or a fact that they're stating, they should have a reference on it. And then if you want to know more, you just follow that number reference and you can almost kind of dot your way around the papers to kind of hone in a bit more on what you're looking for.
Yeah, that's a great advice. Actually, not what we're here to talk about is academic work,
No.
but I will get
I
this
wish
podcast
you'd done all that.
swiftly back on track. Today we were talking about yeast repitching and health, of course. So I think just a really good opening question and probably eye-opening for some brewers who may have this answer wrong, but like what types of yeast are repitchable?
So I find it really frustrating that it's so uncommon in the brewing industry to repitch yeast, but I appreciate it comes with a little bit of kind of equipment requirement, I say, but not huge capex expenditure equipment requirement. It's a lot more accessible than I think a lot of people think, and it's a lot safer than a lot of people. I think a lot of people are afraid of it. Yeast is the only raw ingredient that you are, as a brewer, putting into your beer where you get more out of the end that you can use than you put in. When you do your dry hop, you don't get 6 lovely foil wrap bags of hops pellets at the bottom that you can put in your next brew, and it will save you all of the money. So it's a real trick that people are missing there, and it's definitely worth investing in some of the equipment to be able to repitch yeast, because all brewing yeast is repitchable. Yeast is a single-celled organism which will replicate itself and clone itself, not exponentially, but if you have enough cells, you can keep repitching exponentially. It's not recommended to repitch from really high ABV beers, or if you want to talk about biotransformation, if you want to add a really early dry hop, not recommended to be cropping yeast off post dry hop. Sour beers or low alcohol beers are also probably not the best beers to be cropping yeast off of for 2 different reasons. You're going to end up with quite stressed yeast that's in a really low pH environment if you're cropping from sour beers, and low alcohol beers, you don't get enough cell growth because the fermentation is so short that you wouldn't get enough biomass to repitch that. The other thing is to try not to repitch between beer style. When I say styles, I really mean color. Although it's something that I've seen in commercial breweries done successfully and surprisingly doesn't affect the finished color of the beer. But yeah, if you're a smaller brewery and you haven't got that control over that process and you haven't got the yeast propagation systems and you're just doing it cone to cone or into a keg and then into the cone, it's probably best to keep the color of the beer the same. Otherwise, you might end up carrying over some of that color or some of those roasted flavors from, say, a stout into a pale ale. Yeah. Also, the quality of the yeast. If you have a fermentation which is slow or sluggish or has done something that you didn't anticipate, maybe don't use that yeast in the next beer.
Good, solid advice. Yes.
Or
It's
do.
quite. Yeah, all do,
Do
and then figure out a way of solving those problems. Yeah, I think it's a good point that like all yeast. I mean, you're saying that even dried and versus wet, it's all
Yeah.
repitchable, right?
It's all wet yeast after the first brew.
Exactly.
The difference between dried and wet yeast, when you're using wet yeast, you will need to oxygenate on first pitch. When you're using dried yeast, because of the way that the yeast is grown before it's dried, it contains all the sterols, which are the compounds which are needed to protect it from stress. So you don't need to oxygenate on first pitch of dried yeast, whereas you would for a wet yeast. But going forward after that, you do get slightly lower viability at the end of dried yeast during the first pitch. But in contrast to that, you also have a much greater cell density than you do in wet yeast. So the pitchable amount, you will have more cells. So that kind of balances itself out.
It's interesting. I didn't know that. That's really cool. So, I mean, like now that everything is repitchable, how do they assess that yeast that can be repitched?
So all yeast will come with a range of figures. A lot of people don't look at these. They kind of just look at the attenuation and the fermentation temperature and then just go ahead. But all your yeast will come with a TDS, and that will show you kind of different qualities about your yeast. So how many cells it has, what percentage of solids it has, what its viability is and its vitality, as well as what wild yeast has been assessed to be within it. So a lot of brewers, they think that these are completely pure cultures that are being sent to them. That isn't the case. It's impossible to test down to 0 cells. So it will be a range that you're presented with, and normally it's like less than within a range. And so if you're looking to repitch, the things that you're looking for are the lowest quality, like the lowest quantity of bacteria, wild yeast. And you want to make sure that your producer who's producing the yeast has the accountability and traceability for these numbers, as well as the thing that everyone was scared of in about 2008, diastaticus.
Oh, yeah.
I mean, I feel like people are still scared of it, but it was definitely a bigger thing when I first started brewing. I absolutely remember. So there is a gene within yeast called the STA gene, and this basically if your yeast has it and it's STA positive, then that means it has diastatic power, which means it can break down long chain unfermentable sugars into fermentable sugars. The only problem with this is that tends to happen very slowly and after the beer has been put into packet. So it will lead to exploding cans, over attenuating bottles, over fobbing of kegs. So that's a quality that is really important to look at when you are reproducing your yeast along the line. So Lallemand have all of our yeast have STA positive or STA negative declarations on our TDS. We think this is really important for brewers to know, especially if they're repitching. And we're currently working with to work out a standardized method for testing for STA, because currently there is no standardized method for declaring whether yeast is STA positive or STA negative. We obviously have our method, which we use and have been using, but we think it's important that everyone is using the same standard of method.
100%. Yeah. So how would that's really interesting, actually. Do you know what? I've probably had loads of TDSs. You look at it maybe once and then you might not look at it for a while and then you forget those numbers. So yeah, a really good thing to check. And it's also traceability on everything, of course, as you said, is really essential, especially with yeast. I mean, of all the raw ingredients you put in, it's probably for most brewers, one of the most affordable.
Yeah, I think it's important something to look at, but then equally, traceability, especially if you're repitching yeast, is hugely important, because should there be a problem and should you have gotten, heaven forbid, a batch of yeast that wasn't what you expected it to be, or wasn't to spec you expected it to be, or you've managed to pick up an infection, you need to be able to see the traceability of where that yeast has gone and what batches of beer it has gone into. And I think that is where a lot of the fear comes from a lot of brewers when I say, hey, why don't you repitch your yeast?
Mm. So I think it's interesting to talk about bacteria as well as this. So how can brewers ensure that what they're pitching into their first and repitching doesn't have contamination in, that's bacteria or wild yeast?
Yeah, so there's a couple of different ways to kind of approach this. So regular micro testing is obviously important. You have your TDF, you look at your bacterial counts, they're normally written in terms of colony forming unit per gram or colony forming units or CFUs per number of yeast cells. There's a couple of different ways that it's written on TDSs. So you might need to do a little bit of kind of math to work out how different brands compare. But if you're repitching and it exacerbates a problem, you're only going to make that problem worse by keep carrying it down the line. So things like sending off beer for regular microspecs, ATP testing after CIPs, just kind of the basic cleanliness, beer, and auditing, and like making sure that your processes are working in the way that you're anticipating that they're going to work, so you don't pick up any infections or you don't have any problems further down the line. A really crude way of measuring whether you've got a problem in your beer that you can do in-house without having to spend money on external micro, or if you're lucky enough to have a lab, then you obviously can do that yourself. A crude way of doing that is something called forced ferment that I don't think enough people use. So a forced ferment is basically just taking the yeast and the probably partly fermented wort directly from the FE. So every time you do a brew, taking a crop of the yeast off the bottom, just on like day 1 or day 2 of fermentation, and putting it into a flask along with beer from the sample tap. And then that will give you the microorganisms that are within that tank. And then if you can put that on a stirrer plate so that it's constantly agitated, if you can put it in a heated, what is the word? An incubator, then you can end up basically forcing that yeast to finish fermenting right to the very end, so you will get your final gravity. So you will get that within a day, 24 hours, 48 hours, whereas the beer might take a bit longer. So it will give you an early warning sign should there be an over attenuation problem. Please don't use this as, oh, my forced ferment smells weird. Yes, will smell horrible because we don't ferment beer at 40 degrees or 35 degrees or however hot you've decided to do it. And we don't try and ferment beer as fast as humanly possible because that isn't really kind of how the best beer is made. But it will give you an early warning sign of infection, or if you have too many fermentable sugars, or maybe you've messed up a mash temperature. It's a really inexpensive way to sound an alarm or raise a red flag for that specific batch of beer. Don't take yeast from a different batch, and well, you can do that if you want, but you won't get a representative sample of that tank.
Yeah, so that's one of the key things, isn't it? Getting that original yeast right, because I've done it many times with a few different breweries I worked in, and some really successfully and some not so. And I think a lot of it was taking yeast from different tanks, spinning, like we used to spin the yeast, put it in large, like one big batch, spin it all out and then add that in. But I think that was definitely changing the attenuation limit. We weren't getting very representable samples, but I do love the forced ferment test for that. And I mean, not that it's necessarily to do with yeast repitching, but I think forced ferments are an excellent way of, let's say you have to make brew a beer 6 times over the next 2 weeks, and it's a new beer, it's a seasonal, or it's for a specific contract, and you want to ensure that you got your mash parameters and pitching rates and everything correct. It's the best time to do it is on that first one with a forced ferment, and then that you're right or that you're wrong, and you can make changes to the adjusting recipes before you wait the week for it to finish and go, oh god, that finished low, and then you've got 5
And
more
you've already
batches.
brewed another one.
Yeah, 5 more batches. I mean, there times where we have 5
More
or
than
6 or
5
7
batches.
batches.
Well, that was a shame.
Like, well, we are. So
Honestly, I don't see many breweries using them, and I think it's such an easy rudimentary tool to work out what your fermentables are in your batch. A lot of people don't realize that they might have got the mash temperature 1 degree out, and then it goes around in your head, I think, that, oh, there's a problem, something's wrong, it's an infection, it's whatever, but it could just be that's the fermentable sugars of this batch, and the temperature was slightly off, or the other thing, which is off topic again, but is my pet peeve in breweries, and you had the episode on be your own brewery consultant kind of thing, but people checking whether temperature probes are calibrated, that is, people go, oh yeah, the tank is at X degrees. And I'm like, okay, well, have you taken a sample out of that tank and seen that it's definitely at that temperature? Because I've had it where a temperature probe's fallen out the back of a tank before. So that's my other pet peeve of the life of a technical salesperson / essentially brewery consultant.
Yeah, it's so funny. I spend a lot of time with the team from Murphy's, and Fran from Murphy's always tells me exactly the same thing. It's like someone said, "Oh my god, they've got this massive problem. Like, have you checked the numbers that you're receiving are correct?" And they come back, or they don't get a response, and they're like, "Yep, they've sorted that issue out." Then,
Yeah. And
always the case.
I always hate asking the what I would define as like the basic questions. Do you know what I mean? But sometimes you don't ask those questions, and then it turns out to be that, and you're like, oh, I just presumed that we were at that point. We'd already covered those bases before you even phoned me.
Yeah. There's a really good MBA podcast on this exactly, where they go through actually a similar thing to what I did, but they did it on it was like a bunch of students had done a paper, so a bit more legit than what I did. But yeah, they went through it and they were like doing all these fish diagrams to try and find out what this problem was with some sort of number, and it just turned out the density meter hadn't been calibrated. And it's like a whole hour-long ordeal, and you felt like, oh, I really want to know the answer, and then you get it, and you're like, oh, yep, that's really annoying. No, yeah, it's just classic though, isn't it? Just validate the numbers that you're getting. Okay, let's
And so validate your FG with man.
Okay, cool. So how sensitive and delicate is cropped yeast?
Everyone is so afraid of cropped yeast until you worked in a brewery that has repitched yeast. I think the minute that you've worked in the brewery where you've repitched yeast, you realize how hardy the liquid that you're cropping off the bottom of a tank is. And I think that's what a lot of people's fear is based around is, oh, this is so prone to infection. This could be awful. It could exponentially make all my problems worse, but it also could exponentially save you money on your yeast. So I think the thing to think about is that when you're cropping that yeast off the bottom of the tank, that liquid that you're taking off the bottom has a lot of things in it that will stop it being susceptible to infection. So it will have alcohol in it. You're quite happy to put the liquid from above this yeast into a bottle and say it's stable. But the minute you take it off the bottom and you put it into a keg, or you put it into a bucket, or you put it into a sanitized tub, then that becomes scary. So you'll have alcohol in there because you have alcohol in the tank, and that's a preservative. You've got very little or no fermentable sugars, hopefully, because you've finished fermenting your beer. You've got your bittering hops in there. You added them in at the start of the boil, and hops are a preservative. You've also got billions and billions of cells of yeast, which you actually don't have in that bottled beer that you're quite happy to put on a shelf for a year. The billions of cells will outcompete most things. So you need to think of the yeast from finished fermentation, like the beer, which you will package without filtration, without pasteurization, and say this is a stable product. And as long as you're moving that yeast either from cone to cone into a sanitized vessel, or into a tub or a sanitized lidded bin, or a prefabbed keg that you can purge with CO2 and stuff, and you can bleed out the top, absolutely it's safe. If you go into the traditional breweries that have been going for hundreds of years and have their house yeast that they've been using for decades sometimes, and you see how they're repitching their yeast, I think a lot of people would be less scared of repitching yeast. I'm not naming names. There are people who do it in just a black bin with a lid on it, not airtight, just clipped on lid. They sanitize it every time on a spray ball, and then they put it in the fridge. And they do that for 15 generations of yeast and don't see any problems, and have been doing it for hundreds of years. So I think it's good to have all the equipment, and it's good to have all that kit, and absolutely you should be quantifying your CIP process and making sure that it works properly. But there are breweries that repitch using bins.
Yes, it's a good point. I've definitely been more on the cautious side of my career, but you're right. I've then been to breweries and been like, oh wow, okay, this is how it works then. I mean, actually, the first brewery, if I really think about the very first brewery I worked at, was just skimmed off the top. It was top fermenting yeast. Anyone who's worked with top fermenting yeast or open top fermenters knows how inherently unsanitary that process is of cropping and everything. So, and it's all open top, and it kind of like, I always feel like when you've got those conical fermenters, you become so afraid of open air.
Yeah.
It sounds kind of
Yeah.
daft,
Yeah,
but
definitely.
and
And
then
those
like
open
you
top
go to an
fermenters.
open top fermenter brewery, and you're like,
Yeah.
how do you live? How do you survive in this
Exactly.
area?
Well, it just is. You've got positive CO2 coming
Exactly.
up the top. There's, and
Yeah.
I think it's, and I do agree, brewing absolutely is 99.9% cleaning and everything should be clean and sterile. But that not at the expense of not doing a process which will save you money
Yeah.
because you're scared of it, because you think that it for some reason inherently won't work when I can demonstrate that it works for you exactly the same way for hundreds of years, just using very rudimentary buckets.
So it's perfect. Yeah, that's really interesting. I mean, I guess most people listening to this now will be like, let's get to the most important thing, which is how much should you repitch? And then part B to that is, how do I know?
Yeah. So 1 bucket load per tank. Um, no. Kind of start this process off. If you want to do it, you want to quantify how many cells you're pitching. You want to make sure you've got healthy cells that have intact cell walls and are still going to be alive. So the basic things to invest in would be a microscope, and it would be a hemocytometer slide. So a hemocytometer slide is basically a glass slide that fits in your microscope, and it's got a really tiny grid on it marked out. And that will allow you to count how many cells there are and measure the viability. The thing with doing it like this is there is variability between people. So if you have numerous people who work in your brewery, training people to the same standard is really important, because when you have counted a very teeny, tiny surface area and have said there are X amount of cells on that, and then extrapolated that to 30 hectoliters, you're going to have a huge difference in number if someone missed 3 cells or heaven forbid haven't counted any of them. So I think that's kind of where to start. If you don't have the budget for a microscope and you don't have a budget for the hemocytometer slide and you don't have the budget to do that, but you do have the equipment and the sanitization and you're happy with like ATP swabbing bucket, but you don't necessarily, and you have oxygen, we'll come on to that later, then you can do it by weight. A lot of the breweries that I've worked at that have been repitching and have repitched consistently don't bother doing the cell counts every single time. They just do it on kilogram weight. And when you're cropping off the bottom of a tank, you'll be looking at that sight glass and making sure you kind of end up judging what good yeast and what kind of thin beery yeast. My kind of, what I was always taught as a scale was that you drop off that first tiny bit of the cone. So at the very, very bottom, you've got all the very, very dead cells, and you're dropping that down the drain. And you want to make sure that you're taking off the yeast incredibly slowly so you don't pull a hole through the middle of the cone. But basically, the yeast you want is that bit in the middle that's settled out in the bottom of the cone. And you want it to be thick and foamy and kind of like a banana milkshake from McDonald's. Other milkshakes are available. And I was always told that you can kind of do this with a hose and a bucket, but like as you're kind of cropping the yeast off or dumping the yeast off, you'll see that really thick yeast. And then if you're smearing it kind of on the side of a bucket, once it starts washing that kind of gloopy yeast away, and it's a lot thinner, that's kind of more beery yeast, you'll have a lower cell density there, and that's kind of when you want to stop cropping. Obviously, if you're doing it with a bucket and a hose, then you want to make sure all of these are very, very sterile. If you're doing it in a closed system with a keg and a sealed system, then you want to make sure there's a sight glass and you've got your keg on a scale and you're basically tearing the scale, fill it with yeast, see how much yeast you get, and then repitching that in. I think this was a long time ago, but I think the numbers that we used to kind of roughly go on was about 45 kilos per, I want to say 30 heck. I think it was about 45 kilos per 30 heck. I don't know if that matches up with your kind of experience.
Checks out. Yep. Yeah.
Okay. Good. I haven't got that completely wrong. If you don't have the microscope and you only have the bucket and the cleanliness and the wherewithal to have a go and the oxygen, then that might be a good starting point. The thing with dried yeast is that you can always have it on hand. You can always have it in the fridge. It's got such a long shelf life. You don't have to order it for a brew. Is that could you have underpitched it a little bit? You can always chuck another packet in the top, and next time up that kilogram per litre amount, just to kind of get that cell density higher. But yeah, I don't think the brewers that are repitching it all the time are doing cell counts every time. I might be completely wrong, and they're super diligent, but a lot of the time it's done on weight.
Yeah, I spent a lot of time with microscopes throughout my career. I guess I don't want to say fortunate, I guess, but just worked in breweries that had them. And I worked in the first brewery I worked at didn't have a microscope, and it was exactly that, pitching the same amount of buckets, or roughly amount of buckets every time. And it works for sure. I would say it's limited, but naturally, but it does work in the sense that you will get beer that ferments and it will taste somewhat the same most of the time. But I think, I mean, you've definitely seen it yourself, Alex, that when you look at them under a microscope, the count does change fairly regularly. So
Yeah,
I would always advise anyone that how much is a microscope these days? They're not
less than £100.
less than 100 quid. And I would say that if you repitch once, you'd be able to save, or repitch one batch of yeast 5 times, whatever, you'd save that money. So I would say it's a good thing to do. I also love the fact that you get to visually see your yeast every day. You just learn more about what is good, what looks healthy, what looks unhealthy, and what is a norm and what isn't. I've had some amazing catches before from people who've caught things in beer, in bacteria, and in yeast, caught so much, and seeing like, well, that doesn't look right. Let me go look. You look and you go, that does not look right. That's very unhealthy yeast. And it's just a really nice way of catching as well. And just get to know the process, get to know your yeast a little better. So I'm a big fan of the microscope and counting and pitching. But what it should definitely teach you is that it's not always an exact science, and nor should you be. You don't need to be overly exact with it, I
Yeah.
guess. But what would be like the effects of underpitching and overpitching?
So underpitching, obviously, you'll end up with maybe some off flavors, maybe some stuck fermentation. This is why when you do the forced ferments, then you can see whether you've either underpitched or you've messed up your mash temperature and you've not created the fermentable sugars to start with. Overpitching, probably slightly less common, but yeah, you can lead to fewer daughter cells being created. So fewer of those new freshly budded cells being created. So because there's loads and loads of biomass, you get less cell growth because they don't need to keep replicating. And then that can affect the future fermentations going forward, because you want a good mixture of mother and daughter cells to get that healthy fermentation. And you're going to need every single batch of beer to produce some more daughter cells to keep that going, so that you keep getting healthy fermentation. It might not necessarily affect the batch it goes into straight away with the overpitch, but it might affect the next batch.
Great. And we're talking about earlier a little bit about cell viability. How do you know how many viable cells you have in your yeast pitch with a microscope?
So you got your microscope for under £100. It was a bargain. And you got your hemocytometer slide, which actually, to be honest, those are surprisingly expensive.
Yeah, and you don't want to go cheap on them.
No,
Go cheap,
you
and
don't
they
want to
look,
go cheap on
you
them.
won't be able to count anything.
Yeah. Yeah. I mean, that all these people will get the microscope and then they'll be like, I can't even see anything down here. And it's because you cheaped out on the hemocytometer. Weirdly expensive, but worth the investment. So you've got your thing, you've got some methylene blue. You're going to basically use the methylene blue as essentially a dye. So when you mix it with your yeast, diluted kind of yeast sample, it will basically stain everything that it can enter. So to find out how many viable cells you've got, you're going to basically smear this mixture of dyed yeast onto your hemocytometer, which has this like grid system on it. You're going to focus in on it, and you'll be able to see the circles of the cells, which is what you were saying earlier. Is you can see whether you've got cells that are a weird shape, and they might not necessarily be your cells. They will be possibly an infection or signs of a bacteria or signs of a wild yeast. So these are all things that you can look at the same time. But basically, concept is you want to count all the cells that are alive and count all the cells that are dead and work out it as a percentage. And the reason that you can tell which ones are dead and which ones are alive is that if the cell wall is intact, then the dye will not enter the cell. Whereas if the cell wall is broken and the cell obviously will then not function, then the inside of the cell will look blue. So that's kind of generally how you would find out how many alive/dead cells you have. And then from that, you can extrapolate how many cells and therefore how many grams you would need, or kilograms, or whatever, how many buckets you need to pitch into your tank.
Yeah, and what's the rule of thumb around like? Would you agree like anything above 90% viability is pitchable? Anything below you should probably think about.
Yeah, I think it honestly depends on the brewery. There are breweries that would go lower than that, but as a rule of thumb, I'd go over 90% viability is probably over 80% is good. And then, yeah, anything kind of below that, I'd be looking at either starting a fresh pit or adding in some additional yeast or from a different tank, or from a different lineage, like as in from a different chain of yeast, if it's the same species. So yeah, I will be looking at that. But then that kind of leads into how many times do you repitch? And some people would say hundreds of thousands of times,
Mm-hmm.
because we've been going hundreds of years and this is our yeast. But I would say probably 5 to 10 generations is a good rule of thumb. You need to remember that that's exponential and not linear. So your one brew of beer will probably have enough yeast to pitch into 2 batches. So you're going 1 pitch to 2, 2 to 4, 4 to 8. So that's not just I will have five beers. That's 5 exponential times. So yeah, I think it ultimately, to be honest, to save money, if you're worried about contamination and you're worried that you're not going to be able to do it right, or you're not going to get it right, then even just repitching once into two tanks saves you enough money to not have to have yeast as such a high percentage cost of the finished beer.
Absolutely. Yeah, I think from my experience, 5 to 10. I've been in breweries where have gone 30 plus. But I don't think you can pitch that amount of times without some form of genetic mutation. So things will start to be different, I guess. Smell slightly different, taste slightly different, the abuse or act slightly different. But some breweries can completely fine with that. Some breweries want less, so we would always go between 5 and 10 in my later years. I think is a pretty good rule of thumb.
Yeah,
Yeah.
I think the opinion of some brewers is that the second and the third generations are the best generations, and they're the ones that taste the best and they act the best. And but
Love
yeah,
that for brewer who says that. Yep.
they used to tend towards how you're using it. Do you know what I mean? So I've had no problems bottom cropping lager yeast. So the more you, if you're cropping yeast off the bottom of your tank, that's the yeast that has dropped very well to the bottom of the tank. So the next time you brew it with it, it's going to drop to the bottom of the tank, because that's where the biomass has kind of, that's where the genetic material has come from. So the more you use it, the more you are using it in the work and the fermentable sugar matrix that you have, like what proportions of fermentable sugars you have. The yeast that ferment the best are the ones which will survive or would drop out. And if you've got, I wouldn't repitch if you're going over 60 IBUs, but if you've got like relatively high IBU, then those yeast will become more adapted to fermenting in those higher bitterness environments. So yeah, it's an interesting concept, but it's actually one that we use ourselves to create new yeast strains, is adaptive evolution, like lab evolution. So we'll do this in at lab scale, and it's basically survival of the fittest of a new strain of yeast. You have a bunch of different options of what could be a viable commercial yeast. And if for our new yeast Pomona, Escarpment Labs went through the adaptive evolution process where they grew it in heavily dry hopped worts. So the ones that worked really well in those worts were the ones that they were selected from. So as you keep repitching, your yeast in theory will kind of not specifically adapt within 10 generations, but the stuff that you're cropping will be better at fermenting the beer that you're creating.
Yeah, that's really good. I love that. And yeah, I agree. It's kind of counterintuitive, I guess, and things you read and what you understand about yeast. But yeah, you can definitely crop bottom from lager yeast, etc. The first one could be a bit difficult. I've had experience with that where it's like, why? Because often lagers initial cell counts are much higher than ales. So you've got that challenge and the fact that it's not dropping very easily. I've had that before. But I've got a question for you, Alex. How long would you suggest is the maximum amount of time that you would leave the yeast in at the bottom of the tank, let's say, before cropping? So let's say I've chilled my beer down because I'm ready, but there's a delay. How long would you leave that yeast in there before you would repitch it?
So when I worked at a brewery that repitched, we did 10 generations. I think we managed 7 different yeast strains across all of the brands. It was kind of mental. But I never dropped the temperature down when I cropped. We were cropping, the indicator for cropping for us was, you see, as the gravity drops down after pitching, you started at your OG and you see that gravity dropping down. You see the pH drop down as well from like 5.2 down to like 4.2. And at some point you'll see that pH slightly go back up a little bit. And that basically just means that the yeast is dying, because dead yeast have a higher pH than alive yeast. So our indicator was always that little blip in the pH as it comes up a little bit. That was when that day or the day after we would then crop the yeast off. I think you make an interesting point that it's difficult to crop lager yeast, especially the first pitch. But don't be afraid to crop off the good quality yeast and the foamy, thick milkshake stuff first. And then if you don't have enough, just wait another 24 hours, put that in the fridge, obviously. And then you can always top up again. You could always take another little bit. You don't have to do it all in one go and then panic because you don't have enough. You can always come back the next day and take a little bit more yeast off the bottom because it probably will have dropped down. But yeah, dropping the temperature down obviously will encourage that yeast to drop out of solution. But yeah, I've always had experience doing it just at fermentation temperatures.
That's interesting. Yeah, I've never done that before. That sounds cool. I mean, if it works, it works. That's great.
Well, or not cool.
Oh, well, not cool. Oh, jeez. It's funny. Yeah. Well, what are the methods? So we got the bucket method, right? We talked about what other methods could brewers use to repitch? I think one I've always used is cone to cone through a flow meter. So you do a cell count with a microscope and the hemocytometer, and you'd be like, okay, my viability is this, and my cell count is this, and that I require X amount of cells in my new beer. So I'm going to send with a small Excel calculator. You can work that out. It's pretty tough calculation on your calculator. And then, you just be like, okay, I need, let's say, 100 liters of yeast. And then you would just do it through 100 liters. And then you put through 100 liters. And you roughly be around there. And then you do the top up or not. Is there any other methods of?
I've used kind of retrofitted 50-liter keg, which basically just have a valve on the bottom and then a tri-clamp kind of fitting on the top with another valve and a gas bleed valve. So you can use CO2 to push the yeast into the tank. You can also use it to be you can purge through that. But yeah, you then would have to have X number of kegs for the number of yeast or the number of times you need to repitch. Cone to cone is definitely the easiest. The only constraint by that is your brewing schedule. So if you are using numerous different strains of yeast or you're not brewing very regularly, then that isn't a method. You're going to need to store it. So finding something that's an airtight container, preferably, keeping it cold, bleeding off the CO2 every day so you don't get it too big a pressure in the vessel. You're basically just trying not to stress the yeast out. But I have found you probably want to pitch it after a week. I have successfully repitched yeast that's been stored for a bit longer than that. Honestly, you just get to know the yeast that you're working with and what works for you and your brewery and the beers that you're making. But it's easy to say the science and you count the number of cells and you put that in, but there is an element of trial and error to it as well.
Mm-hmm. Yeah, because I was once very frustrated by the lack of accuracy or like repeatability of it. And as you said, made a really good point earlier about cell counting. It's done by different people. And also to even take it back one step further, you're taking 1 mil or 1 gram of yeast or one mil of whatever you're tasting and pretending that that's the exact same across 3,000 liters, 5,000 liters, 10,000 liters, whatever it is. And so you're just going to have levels of inaccuracy. So you just have to sort of understand that. And I think also if you're doing cone to cone, there's also a good point we always found that you measure, let's say the bottom of you've taken off that first bit of trub and dead yeast, and then you count that. That's not replicable of the rest of the yeast that's sat on top, because that's the thickest pure. So it gets progressively thinner. So we just put little correction factors in there. So nothing's perfect, but again, it's just making sure that you get that you get the yeast you need. What I've always done, I learned this from one of the breweries that I've worked at, that we always used to do yeast counts of the tank that we've just cast it out into from the brew house. So put your yeast in it, put your repitched yeast in it, you put your wort in it, and then we would take a count there. And if that count was accurate, was in spec, sorry, then we would say that beer is going to be okay. So that's a nice foolproof way of, because at
Well,
the end
you've
of the
got
day,
you've got a mixture of the yeast you're pitching and the wort, and it's dilute. So you're already kind of, the odds are against you that you're gonna overcount that.
yeah, exactly. And because you don't have to dilute it like you would the yeast, you have to go 1 to 100 or whatever. So it gets inaccurate there as well. So I always found that was a good count. And if it was super low, then we basically assume that and there was a problem in the pitching or something. So I think that's a really good count to do. It's obviously a little bit of extra work, but it's kind of the be all and end all. And it's the best place to catch an underpitch is at the start before fermentation starts.
Well, you can do something about it on day 0.
Exactly. Yeah, it's nothing worse than getting me like, ooh, this beer's lagging pretty badly.
Yeah, exactly.
Which actually leads to a good question. How do you assess? Let's say you don't have access to all of this, or you're just new to repitching. What would you recommend people do to what are the call signs of an underpitched or overpitched or basically a problematic repitched beer?
So you're looking at lag times, incomplete fermentation, slow fermentation, off flavors, yeast not settling out, like basically anything that you can think of as bad beer or an indicator of bad fermentation is possibly, not always, caused by yeast. It doesn't just make alcohol. There's lots of other things that yeast does within beer. So it plays an important role in especially in the flavor. I think a lot of people don't. They obviously do their gravity and pH checks every day, but I think a lot of breweries don't taste those beers as they're fermenting. I would always take a little sip of the sample, even if it's just essentially wort. You do learn, if you can learn your own beers and learn how they taste at different stages. Again, that's a really good indicator of problems down the line without just looking at some numbers on a table. It's the same thing as I was saying with not actually checking the temperature of the beer that's in the tank when your temperature probe says it's at a certain temperature. Being hands-on with the beer that you're making and getting to know kind of what that looks like at different stages is a great way of finding out if there's going to be something wrong with it or that you've underpitched it. But yeah, definitely having a look before on the day 0 is a great way of checking that you haven't underpitched it. There's also some of those indicators play into when you should stop repitching it. So if you do get some weird off flavors or you get some variation from a standard brand that you make, or you've got a slow or laggy or incomplete fermentation, then those are all indicators that you should probably stop repitching and go with a fresh pitch of yeast for the next brew. If your beer is not in spec, then go back to the drawing board on yeast or finings or ingredients or mash temperatures. Like, this is why we record all this data. It's not just that we've got folders and folders of bits of paper.
Yeah,
it's the rest of the cat.
Yeah. Yeah, I think one of the most common themes throughout all of the podcast guests and episodes I have that are around a similar-ish topic of anything to do with brewery, everyone says taste everything as much as you can. You can catch so much more with your taste than you can with analytical equipment, and much sooner. So
don't taste
well.
EAA or the caustic though.
That one didn't appear in the CIP episode, thankfully.
Have a little sip.
Just edited that part out where we were talking about the sensory analysis of caustic. But yeah, I think it's just so important. It's so easy. I mean, to be honest, sometimes it'd be a bit of graft to taste little samples of beer all the time, but just little sips here and there. I think and you really get to know everything about the process of the fermentation. I guarantee you do it for 3 months, you'll find things way quicker and be like, oh my god, this is actually doesn't taste right, and then you'll know you can then try change that before you dry hop it, for example, where all the money goes in. So there's loads of things
you definitely it's feasible to do that without having to have a tasting panel and a designated time for tasting. Like, so when I was cellar managing at Wild Beer, we had 16 FVs, 6 CTs, and we came in the morning and we'd do cellar check at like 6 a.m. and I would line up all the little pots and the little filter paper, put all the little filter papers into the little funnel, and then I'd pour them all out. And I'm just super weird, and I would make sure I would do the gravities in one direction and the pHs in the other directions and fill them in on a cellar sheet. But every single one of those samples, not the filtered one, because they just taste like filter paper.
They do taste like filter
but
paper.
every
Yep.
single one of the like pH samples, I would, just before I poured that down the sink, I would have a look at what it was, and I would taste it, or I would try and test myself, and I would have a little sniff and then be like, oh, that's that at the point. And you can, and I think there's a real benefit in having those written records and having someone come in and do that every day. But we would do that at 6 a.m. and then we would have our meeting at 7 a.m. of like, this is what this is what the stellar plan looks like for today. This is what we need to do. This is where this beer's at, and kind of just taking stock of where every tank is at and having tasted it. And that was done within an hour for one person for 16 FVs and 6 CTs. You're not that doesn't take a panel of experts at a specific time on a Wednesday afternoon to taste everything. That's just feasible for one person to do. And yes, there'll be variability between people, but if everyone's doing it, then you're going to catch things, or you can even compare notes if you do catch something.
Yeah, and I think they work both in tandem. You make a good point. We covered sensory quite a lot, both with Jethro with a two-parter, and also with Tanya as well, on a whole episode on sort of how to build a lab as well. And it sounds very intense. Probably actually what we just missed off sometimes is just, there's no harm in just building your own profile of what everything is and just tasting them yourself, and just maybe you can record things, or maybe just keep it in your head. You'll know through repetition. I'll just be like, that doesn't taste right. And then, so I agree. I think it's a really cool way. One thing, especially is working for Lallemand now, you have a lot of access to what is really good yeast nutrition. So if you could just give us like what brewers should be doing to ensure the health and nutrition of their yeast for repitching.
Yeah. So the big key thing is, if you don't have oxygenation of your wort, please don't repitch. You need to oxygenate wort on second pitches of yeast. If you're going to be cropping and repitching, you have to oxygenate that wort. You can't rely on the drying process that the yeast has gone through to provide the sterols. That you need to provide the oxygen so the yeast can create sterol, because otherwise your yeast will not do anything. So, and it's not just a case of, I'll just splash it into my tank. That won't pick up enough oxygen. It needs to be pressurized oxygen that's added inline into cold wort, because as we all know, gases don't dissolve very well in hot liquid. So oxygen is the key. If you're going to be repitching, as well as those lovely buckets that you've gone out to your garden centre and bought, you also need oxygen and a little flow meter and a little carb stony kind of inline. In addition to oxygen, nitrogen, magnesium, zinc, and then biotin, vitamin B5. These are all important things. I think a lot of people are actually adding yeast nutrient into their first pitch anyway, so I probably don't have to go into huge amount of detail with, like, it doesn't vary that considerably. The variability tends to come when you're doing different brands rather than different generations. So nitrogen, or free amino nitrogen, is super important to yeast. It basically needs to be about 100 to 300 micrograms per liter. And if you're not using a majority of standard base malt, you are going to need to think about adding in some yeast nutrient that has nitrogen in it, especially if you're brewing with really high amounts of adjunct or really high gravity beer. Basically, these are all areas where the yeast can be super stressed, and that you need to be providing enough nitrogen, otherwise it won't be able to synthesize enough amino acid. So that's super important to think about. A lot of the yeast nutrient comes as a kind of holistic product. So you can buy individual products to add some of these, like to supplement some of these things, but a lot of the yeast nutrient come as a whole kind of like package. And normally the quantity that you're dosing is dictated by the amount of free amino nitrogen you want to add. So the other things will kind of come along with it, but that kind of qualifies how much of that yeast food you're adding, essentially. So zinc is the thing that's normally lacking in beer fermentations. It helps yeast create alcohol. It's a cofactor for alcohol dehydrogenase enzyme, but it's also a cofactor in flocculation as well as calcium. And once you put the zinc in, within a few hours of pitching, it will all have been absorbed by the yeast. And malt does have zinc in it, but 95% of the zinc that's found in malt is lost in the spent grain. So it's definitely worth looking at adding it. So there's a couple of different kind of methods by which you can add it. So you can add mineral zinc. So this is like something like zinc sulfate, and that will normally come or be listed on your yeast nutrient. But you can also add something called yeast autolysate. I can never remember how to pronounce this. And we're going to go with autolysate, and I'm going to say it again so you can crop it. You can go with zinc sulfate, which might be listed as an ingredient on the yeast food, or you can add it via yeast autolysate. So this is, a word that not many people have heard of or can pronounce, but basically is dead yeast. So this is yeast that has, I did describe this like this to someone, and I don't know if Sarah will appreciate my description of this, but basically it's like foie gras yeast. So we have a product that has basically force-fed yeast zinc. It absorbs said zinc, and then we've killed the yeast, and then we feed that yeast to yeast. So through the process of the yeast absorbing zinc, it becomes way more bioavailable to a live yeast. So they can kind of use that and absorb it much more readily than you would mineral zinc. So it's basically, inactivated yeast, as in dead yeast. So it's not going to increase your fermentation. It's not going to ferment anything, but it does provide more bioavailable minerals and the biotin, which is an element kind of overlooked sometimes that is found in yeast cells already. So basically the yeast can kind of use up the building blocks of this other yeast to the building itself up and create more biomass. You always think more is better, but if you add more nutrient, then you'll get more yeast growth, you'll get more biomass, and therefore you'll create a nutrient deficient environment. So using the recommended kind of dosage rates from products that you're using, that's kind of a good place to start. Should you see fermentation problems, I mean, if you're on generation 10, then put a fresh pitch in. But should you see fermentation problems and you haven't kind of like accounted for high adjunct or high gravity brewing and increased your nutrition to account for that, then you can have a look at reassessing how much nutrient you're adding. But yeah, it's a good rule of thumb to just add some yeast nutrient and add it within the spec that's on the TDF.
That's a great point with the overnutrition.
Yeah.
It's quite common. You think, I'm not sure, so I'll just put in more to make sure that there's enough. And you ironically end up with less.
Yeah, I think a lot of brewers don't realize that you can, by overfeeding the yeast, you make too many yeast and then they all don't have enough nutrients.
Yeah.
I don't think it's really thought of at all.
You also made a point earlier I'd just like to echo because it's something I've had experience with before, which is like poorly fluctuating yeast, and you end up scratching your head sometimes. I don't know what's going on here. But that calcium level, as you mentioned, is critical for yeast fluctuation. So if you're having issues, you listen to your 45 kilos per 30 hex, which actually I was thinking about that for a while. I think that's almost spot on. From my experience, not spot on in general. I just wanted to make that clear. I mean, I'm not the authority on what is correct and what isn't. I just like thinking about trying to do reverse calculations. I was like, yeah, that works. But yeah, you might be like, well, I'm only getting 20 here. This is something unusual. And you might be chilling. That's like we were. We were chilling down and we're like, oh, okay, we're still not getting enough. That calcium content is really important. And what we ended up doing to solve it, because sometimes it's nice to share how you solve these things as well. We took 50% of the salts out of the mashing process and put them into the wort boiling process. So, because they precipitate out. So that's how we did it. And then we ended up with, I used to actually miraculously start fluctuating really great after that. It's funny how simple these things can be when you find the right solution.
The other thing as well, I think I know of a lot of brewers that add the salts in when they mill in, and if they've got an auger and they've got
that's a great point.
It absolutely is hydroscopic and it will kind of clog, and you can notice that even just in the bags of some of the salt. So if you're adding it pre-auger, it can just stick to the inside of the tube, and you actually get none of those salts in your mash. So, and it can work some of the time and then not work some of the time. So like, yeah, there is so much variability in brewing, and it is really hard to problem solve when you're not in a brewery doing it all the time. So the person who knows the most about the beer will be the person who's brewing it every day. And yeah, calcium is sometimes overlooked
Yeah.
in yeast population, or people don't even measure it or make sure that they're adding enough. And also your water analysis from the local water authority once a year. But a lot of times local water authorities are taking it from two different reservoirs, or you're getting a changeover, or your borehole's next to a farm and they're putting loads of fertilizer on the field, or there's been really heavy rain. So all of these things will affect the water that's going in and therefore affect your calcium levels. But there's the variability. You think that water is quite a standardized thing, but it's actually incredibly variable raw ingredient, and everyone loves the water book. So
Yeah, and there's a podcast on this with a guy called Josh Summers on water. We go over that as well, and that reverse osmosis and water actually. But
yeah.
I think another thing I'll just share whilst I am in my memories of the yeast issues that we solved was, and this is going full circle back to the very start of this, where we're talking about why it's important to have your equipment calibrated, for example, or in this case, to understand the method properly. So we were doing viability with the methylene blue, just like you said earlier, and we were counting dead cells, and we were counting more dead cells than, well, okay, there are a few of us were counting lots of dead cells and a few of us weren't, and it was like quite big discrepancies. And just to remind, or just so everyone knows, it's always written down actually when people are talking about counting cells, but when you're looking at through the microscope, you'll see budding cells, so mother and a daughter cell. And if they're budding, then it's unlikely they have the metabolic capacity to withstand the methylene blue. But they actually are completely live and healthy cells ready to go. But they will stain blue because they don't have the capacity to do it, although they're alive. So budding cells shouldn't count. But a lot of people are counting the budding cells as two dead cells. And now you start getting pretty significant, like high viability or low viabilities, and you're like, whoa, this is serious. And actually everything is fine.
There is a lot of variability in looking down microscopes and kind of teaching that SOP, teaching that method. I think it's always best to teach from an SOP. There are machines now you can buy that you put a little disc, you put your little yeast cell, you vein it, you put it in, and it will count it for you. And then that will, in theory, standardize the process. But obviously that costs money. And so if you're not finding those are the problems and you haven't addressed them with other things first, then that might be worth investing in. But you can standardize the process. You can make it completely automated.
The bigger the team, the more valuable the automatic yeast counters become. The smaller the team. If there's 3 people counting, 2 people counting, and I think you can do a pretty good job of doing the same thing every time between 2 people, or even 3.
I will take the opportunity, and you can cut this out if you want. Yeah. Lallemand and White Labs are running a yeast repitching micro course in London and in Manchester. I know, it's fantastic news. So the London one will be the day before London Craft Beer Festival. I think it's the 8th of August.
2024?
2024, sorry. Oh yeah, I forgot. This
podcast is here forever.
Infinitely. This is what my mum meant when she said everything that's online is there forever. August 2024 London Craft Beer Festival on the Thursday at Hackney Brewery. So we've got a space for 30 odd people. We have actual microscopes. You can come and mess around with some microscopes. We have some hemocytometer slides. We will be showing you how in person you can do it yourself to do these processes. And I think it's just a great opportunity to kind of, obviously you've got the networking with other brewers and whatever, but being able to do it hands-on yourself and being talked through the process. I think a lot of brewers learn hands-on, and I think that's kind of, it's worth investing in people's education in that way, especially brewers I've normally find are way more kinesthetic learners than auditory and visual. So hopefully it would be a great opportunity for people to come and have a mess around before they invest money in a microscope and start repitching. And the other one is in Manchester on the 9th of September at Track Brewing
2024. Yeah, that's great. Not that I know anything about these, but they sound amazing. I think anytime you get the opportunity to go use something before you buy it in brewing and just get a feel for it, and you'll see how cool it is to see the yeast, how much you can learn from it. You'll be like, okay, it's good. And just to have good quality microscope skills, really important, because it's easy to buy them and it's very easy to do that incorrectly when you get it, and then you can end up in a bit of a mess. So
I won't name the brewery, but someone did buy a microscope recently and call me and go, I can't see anything down it. So having a chance to mess around with one, kind of do all the silly mistakes where we can help you. And yeah, as I said, I love learning things hands-on, and I think that's really important in the brewing industry. And I think actually probably more than any other industry, people like
Yeah.
learning in that way. So that's why we thought this would be a great opportunity for us to go through kind of go through analysis of yeast and how to repitch and how to best repitch. So hopefully
Awesome.
a good opportunity for people in London and Manchester and around those areas.
I love that. Okay. So is there anything else you want to add here, Alex?
No, yeast is great. Invest in
Ah,
your yeast.
yeah, invest in your yeast. Repitch it. It's
Yeast is
not
the
as
most
scary as you
important
think.
product. That's the thing. If you get bad yeast or you get out of spec yeast or yeast that you didn't think was going to be what it is on the packet or got an infection or the spec isn't good, then that is an entire tank of beer gone. If you get bad malt, your ABV is a bit low. If you
Yeah.
get bad hops, you just add a bit more hops in because it doesn't smell like mangoes. But yeah, yeast is so important and I think often overlooked or kind of the first thing that people want to save money on or not invest in. And I think it's really important to the final beer because you can have to throw away an entire tank.
Yeah, and I think as you said throughout this, it's really not as scary as it seems to repitch a yeast. People have been doing it since beer has been brewed, really. So, well, I feel it was really good episode. I hope the people who aren't repitching, who listen to this, have all the information they do need. If there are blanks that you want filling in, please do get in contact with Alex. Are you okay to be contacted from the
You can
people?
contact me, that's fine. All my
Excellent.
contact details are available on the Lallemand website.
And they'll also be in the show notes, and as will mine, as always. So yeah, thank you so much for coming on, Alex.
Thank you very much for having me.
Yeah, it's been a pleasure, and yeah, I'll catch you around at one of the many brewing events I see you at these days.
Yeah, all of the beer festivals. It
All
is
of the beer
work, I
fest.
promise.
Yeah, no. Networking. I'm networking again. All right, thank you so much, Alex. Catch you later.
Cheers.
Thank you so much for listening to the episode, everyone. One final reminder, if you don't mind, and if you enjoyed the episode, please do share this episode with your friends, work colleagues, or if you can share it on social media, that would be outstanding. Thank you so much for listening, and I will catch you on the next episode of the Modern Brewer Podcast.